So what's the point of this? Hundreds of thousands of spare ventilators don't exist. Engineers and manufacturers are trying to come up with a solution. A standard ICU ventilator is too expensive and too time intensive to manufacture. Instead, we're going to have to come up with a simpler emergency solution, something that gets the job done and nothing more. Something that can be made quickly, easily and in large quantities. As I make this, there isn't a standard design everyone in the world is working on. The UK have announced that they're looking at the PowerPack machine, but this is still a commercial product and not an open source design. Project Open Air are looking to try and quickly realise a simple design that is entirely open for everyone to draw from. The design is likely to be somewhere between an automated ambibag and a PowerPack machine. This mock-up is intended to hopefully generate ideas and solutions for this design. Two features of this design look interesting. The first is that it's entirely pneumatic. There are no electronics, no PLCs and no solenoids or relays. The solution still offers controls for tidal flow and duration of inhalation and exhalation. It would theoretically run from any compressed air source, including compressed air bottles, with no need for additional external power or batteries. The second point is that it's made entirely from common components used in industrial automation. Oscillating an air cylinder like the one shown is a solved problem. The unit being used here is an off-the-shelf unit made by a US company called Clippard. The only modification needed here was to take a pilot line from one of the valves and use it to control an additional exhalation valve. These components are inexpensive, readily available, and exist in warehouses around the world. It's comprised of only 3 valves that can be configured to switch the direction of a flow of a compressed gas from one direction to another. Needle valves let the rate at which the air cylinder extends and retracts to be varied. These specific valves even allow for a delay to be added at the end of each stroke. Another nice feature of this implementation is the way that Clippard have designed and assembled their product. The valves are mounted onto a machine base that has much of the complex paths for fluid flow integrated into it. These machine channels make the footprint of the total unit extremely small and very tidy. It also reduces the number of components that are required and subsequently the number of components that could fail.